Okay, the first is 454590. If you look at this figure, okay, could you use Pythagorean theorem to solve for the length of the hypotenuse? Okay, if you did, you would take the sum of the squares of the legs, set it equal to the square of the hypotenuse. 4 plus 4 is equal to c squared, combining those, and then square rooting. Are there any perfect square factors of 4 or of 8 that you can remove? Square root of 4 times 2. And so square root of 4 reduces to 2 root 2. What you're going to find on this is anytime you're dealing with the 45, 45, 90 triangle, whatever length the legs are, the hypotenuse is going to be that length times root 2. Okay? So in looking at that, you need to be able to do that very quickly so that you don't have to rely on the Pythagorean theorem every time. If the legs are 5, what's the hypotenuse going to be? 5 root 2. If the legs were 9, what's the hypotenuse going to be? 9 root 2. Questions on that? Should be straightforward. It's expected that you know this and be able to identify or apply that very quickly. Okay. It's a little more challenging if they give you the hypotenuse. If they give you the hypotenuse but it's in this form, in this special form, so if they tell you that it's 7 root 2 is the hypotenuse, what's each leg going to be? And so it still fits this pattern, right? It's still a pretty straightforward answer. And the biggest question or the most difficult problem that you'll see with these comes when the hypotenuse is not in that form. So if you're given the hypotenuse and it's not in the form of x root 2, okay? You need to think, though, this value of 10 is equivalent to the x root 2 of that special pattern. And so if you were to solve for x here, it would involve dividing by 2. So really your x value is going to be 10 divided by root 2. Well, if you guys recall from algebra, you can't have radicals in your denominator, so you have to rationalize the denominator, which we will be doing later in the year. But for right now, rationalizing the denominator means multiplying by the radical over itself. And that gives you 10 root 2 across the top. And then what is root 2 times root 2? Root 4, which simplifies to 2. So dividing by 2 is equivalent to multiplying or dividing by 2 and multiplying by root 2. So there's a shortcut for simplifying these. And that shortcut is you take whatever hypotenuse is given, divide it by 2, and multiply by root 2. So 10 divided by 2 is 5, times root 2 gives you the length of each leg. Okay? And so that's the shortcut that you'll use anytime you're working with these. So if I gave you a hypotenuse of 12, what's the length of each leg going to be? Divide by 2, multiply by root 2. Okay? Even if I give you an odd number, okay, so if I give you 17, each leg's going to be 17 divided by 2 times root 2. You're still going to apply that pattern. Okay? The most difficult type of problem that you might see would be something where I give you the hypotenuse, and not only is it not in the special pattern, but it might have a radical in it. So it might be something like 6 root 6. If that's the case, you still just apply the rule. The rule for changing into the length of each leg is you take the given hypotenuse, divide by 2, so you get 3, and multiply by root 2. Okay, so you get 3 root 6 times root 2, which would involve simplifying. 6 times 2 gives you 12. Anytime you multiply radicals, you can combine the product under one common radical. Are there any perfect square factors you can remove from 12? Okay, and the square root of 4 comes out as a 2. 3 times 2 times root 3 gives you 6 root 3, would be the length of each leg. Okay. Now, you could also go directly to this simplified form. This is equal to x divided, or x root 2. So if you just directly divide by root 2, you could simplify this whole process. X is equal to 6, root 6 divided by root 2 gives you root 3, and it can lead you directly to that solution.